Hello everyone. Here is our presentation for the Embark Datathon. Our presentation is an exploratory data analysis on the sepsis dataset. Our team members include Viraj Vijaywargiya, Ananya Amaram, Gavin Lee, and Rahul Kirki. The purpose of our presentation is to analyze the MIMIC-3 clinical dataset to analyze clinical data and make predictions about patients with sepsis. Sepsis can be defined as a potentially life-threatening condition that can occur as a result of the body's response to an infection. We were interested in this dataset as we wanted to use exploratory data analysis to assess projects in the healthcare industry to provide insights which could help medical professionals and institutions in improving healthcare for patients with sepsis. The methods we used in our project are SQL to access the data from the UCI ODIT sepsis analysis dataset, Python, especially the pandas library to create data frames and manipulate the data, and matplotlib and R to visualize and plot the data. Here is our analysis. We analyzed the reporting of sepsis in the medical records of various hospitals as indicated by the dataset. Here is a figure which shows the causes of sepsis and the reporting of the conditions of sepsis in hospitals. Data from the medical reports indicates that approximately 24% of the people who visited hospitals developed some case of sepsis. The condition of most patients with sepsis was reported either as sepsis or severe sepsis, as we can see in the figure here. The figure also depicts the major causes of sepsis as the Streptococcus group D, the Staphylococcus aureus, Escherichia coli, Gram-negative bacteria, and Streptococcus bacteria. Such information could help healthcare professionals and patients be more aware of the causes of sepsis and be aware of how widespread occurrence of sepsis can be. We also analyzed the occurrence of sepsis by race. Here is a pie chart showing the proportion of people having sepsis based on race. The data compares how the occurrence of sepsis was significant among white people and black people as compared to the other races. Here is another figure, which is a bar graph showing the proportion of death due to sepsis by race. This figure compares the mortality rates of people with sepsis across several races in order to observe any clear differences. From this, we can see that among all the races, Middle Eastern and American Indians possess the greatest proportion of sepsis leading to death, while most Americans and Caribbean islanders recovered from sepsis. Suggestions to reduce the burden of sepsis on such groups include receiving proper care for individuals with chronic conditions like diabetes, being up to date with vaccinations, and recognizing clear signs of sepsis. We also analyzed the occurrence of sepsis by gender. Here is a figure which depicts the proportion of males and females having sepsis based on races. As indicated by the figure, we can notice that occurrence of sepsis is higher in males than in females across the different races. The possible explanations could be higher exposure of men to factors leading to sepsis due to improper hygiene practices. Here is another figure, which is a bar graph showing the proportion of occurrence of sepsis leading to death by gender. Figure 5 shows that sepsis for patients in the critical care units is a 60% mortality rate, which is similar in both genders. However, females have a slightly higher risk of death due to sepsis, which is consistent to prior research where women possess a greater hospital mortality compared to their male counterparts. Possible explanations include a gender bias in treatment they receive. Women could be given a less aggressive approach, which could contribute to the slight differences in treatment. We would like to thank you for listening to our presentation and shout out to Data at UCI for giving us this opportunity to present our findings.